So if you've been listening to the other couple of segments, video segments in Chapter 1, you might notice that there's a difference here in my recording environment. I am recording it from my office. I'm actually kind of between chemistry labs, so thus the T-shirt. I don't know if you can see it's a caffeine molecule. But on with meteorology. Now, I had on a previous video looked at surface maps, and weather surface maps generally are talking about weather conditions maybe within 5 to 10 feet as far as I can tell. And how do we get that information? For instance, how do we know what the temperature is, or what the barometric pressure is, or what the wind speed and wind direction is? Well, a number of different ways, generally falling in under the categories of direct measurements and indirect measurements. And I'm going to show you some direct ways that we directly measure the conditions of the atmosphere, just a couple of them for now. But one of them are these cute little groups of measuring devices, collectively called automated surface observing systems. And it's a network of little clusters of measuring devices. Oftentimes, these ASOSs are located near airports because, quite frankly, folks who are flying planes and managing the flights of planes need to know what the wind speed, wind direction, barometric pressure, precipitation, cloud ceiling, all sorts of things, what the atmosphere is doing. And so this network of ASOSs then can literally upload their information, usually hourly or maybe even every 15 minutes, I'm not sure, so that everybody across the United States can know it. So these devices are directly measuring atmospheric conditions. And I think I'm going to try to go ahead and click on this internet. And the site that I'm going to is www.weather.gov/ASOS, ASOS. So I wanted to show you this just kind of briefly. I'm going to click on the map of ASOS locations, and I don't know if you can see, but this is actually associated with the very closely associated with the folks who manage flying airplanes, the FAA, I want to say. So I'll click on the state of Iowa. Here in southeast Iowa right now, I'm located in Keokuk, Iowa. If I click there, there's going to be a link for Keokuk. And voila, this looks like it's every 20 minutes or so, I want to say. Every 20 minutes or so, these collection of measuring devices at the surface near the Keokuk Airport are measuring wind speed, visibility. Let's see, they're measuring sky condition with regard to temperature. What is the temperature and what's the dew point temperature, relative humidity, wind chill, and over here we have pressure. So if you're doing your 3-week weather log, I don't know if I'd necessarily go and get this detailed information, but it's out there. It's a possibility. So here's a photo of kind of a typical ASOS, and you can kind of see all sorts of little gizmos to measure wind speed, wind direction. I mentioned we need to get the cloud ceiling, which is basically the height from the ground up to the base of the first cloud. All sorts of neat things. The other thing I wanted to kind of show you right now is a direct measurement of what past climates have been like. So we have this. These are cores. These are not ice cores, although ice cores would give you some good information. But these are cores that were taken, where the oceans are. Basically, they're sediment cores. So the way the oceans have been is over time we've gotten layer upon layer upon layer upon layer of ocean sediment. So this would be the newest ocean sediment, and this would be like going back in time. So we can get information, a lot of information from the sediment, such as what were the temperature conditions, what sort of gas was dissolved in the sediment, what sort of marine life was there, and that's an indication of kind of the conditions of the ocean at the time. So this would be more related to climates.